Snickerdoodle was, I mean, we created Snickerdoodle. The concept goes a couple years back now, but the premise behind it is basically providing affordable access to kind of this higher end hardware and tools for makers and hobbyists and students, engineers, entrepreneurs, people who might not otherwise necessarily be able to use or afford these kind of things. So we're kind of from sort of a background in developing tightly integrated systems in medical device area, industrial controls, things like that, and realized there were a lot of kind of affordable maker boards out there that effectively give you Linux in your pocket type thing, or something along the lines of an Arduino that kind of gives you these kind of rudimentary building blocks, a really good learning tool for kind of getting started, making things, making stuff. So with Snickerdoodle, we kind of wanted to take that one step further, where kind of providing both elements, both the computational power, that's required, say if you're running Linux, or a lot of people run web servers on their Raspberry Pis, things like that, but also giving people a ton of I/O, so inputs and outputs, and at the same time tying wireless into the whole package. So, I mean, obviously for the most part these days, pretty much anything anyone's building has some sort of wireless element on it. So we kind of jammed Wi-Fi, Bluetooth, an ARM processor, and a ton of I/O all into one little business card size computer. And as Aaron was alluding to before, kind of one of the kind of key to the whole thing, or one of the kind of most important features, excuse me, is this whole idea of reconfigurable hardware and reconfigurable I/O. So not only can your I/O be totally reconfigured, so you can actually adapt it to whatever project you're working on, but you can also actually use the hardware to accelerate specific things. So say if you have some complex algorithm or some sort of image processing application, things like that, that a regular microprocessor wouldn't be able to handle, having both the ARM processor and its reconfigurable element on the same chip actually allows you to kind of seamlessly accelerate those things and adapt things. Sort of like you said, you can change the hardware on the fly. It's probably more in the context of development. So it actually makes it easier to kind of adapt as situations change throughout the course of you building your system, but also after the fact in the field if you needed to implement some new features or new hardware set, new additions, functionality kind of thing to your system after the fact, you can do that as well. So it's a little bit of a different take on the kind of the traditional sort of maker board, which is more of a single board computer style, where you have your standard connectors on there, Ethernet, HDMI, things like that. The interesting thing about Snickerdoodle is it's kind of almost more what it doesn't have, is kind of what makes it unique. So we kind of moved a lot of these bulkier connectors to things like baseboards and whatnot, so you can still have access to them. But if all you really want to do is develop some sort of system that has, maybe it's a mobile battery-powered system or airborne for that matter, and you don't want those kind of bulkier, heavier connectors taking up space in your product, you can get rid of all that to basically just wire directly up to Snickerdoodle and either do prototyping or take a product to market or whatever you might be doing. So that's sort of I don't know, maybe that's a little bit lower than 30,000 feet, but that's the overall idea.